Hello everyone. In this video, we are going to learn a very crucial aspect of programming, which is designing functions. So, writing functions is a core activity that a programmer has to do in order to solve problems. And there are many ways to write functions. Up until now, we have just been thinking of multiple pieces that go into writing good functions. So, of course, we had the function definition, which actually does the work. But then around that definition, we also added other bits of information to make sure that our function is clear and correct. Those bits of information included, for example, the function signature, the purpose, the tests, and now we are going to collect these and look at a recipe of sorts on how do we design the functions systematically. This recipe is taken from the link below. As you can see, this is described in a Racket language documentation, and Racket is a Lisp-based language. So I want to emphasize with this process that this design recipe is language agnostic. It does not take into account if you are using a functional language or a object-oriented programming language or a type language or a dynamic language. So all of the languages would work perfectly for this recipe. So if you go into that link, you will find that there are a few other aspects around it, but this recipe that I'm going to show you will cover the core principles of this design recipe. So what does this contain? So it has 6 steps. Whenever you want to design a function, of course you start with a problem, and that problem then has to be thought out, but you would start off with a signature of the function. We learned in an earlier video that the signature in Elixir is defined by @spec attribute and defines, besides the name of the function, also the type and the number of arguments that it takes and the type of the value it produces. After we define the signature, then we define the purpose of the function. So that is a one line in the doc attribute that tells us what the function is supposed to do. After we define the purpose, then we write the stub of the function. So stub is the scaffolding of the function without the implementation. So it will include the function name and the name of the parameters, and it will be correct syntactically to run that function, which means it will also contain an expression that produces the value of the same type that the signature is telling us to do. After that, the 4th step, we are going to write some examples. So these examples will show some concrete cases where we will write how the function is expected to behave. And we are going to wrap those examples inside tests. In our case, we are going to write unit tests in Elixir to understand how the function should behave in concrete scenarios. Up until this point, you would note that we have not written any implementation, and that comes in step 5, where we start to write the body of the function. So at this point, we will have good amount of information from the work that we would have done in the previous 4 steps to help us write the body more systematically. Once we are done writing the body, of course the last step would be to test and debug our function. At that point, we would have the implementation, we would have the tests. So all that would be left for us is to run those tests and make sure those tests pass. And if they don't, then we would go ahead and debug our function. So that's it. These are the 6 steps that are crucial for designing good functions. Let's use this method to design a function in Elixir for a very simple problem. The focus will not be on the implementation because the problem statement will be very simple. In fact, one might argue that why would I need 6 steps to write this kind of a function? But the point here is not to focus on the simplicity of the problem, but to understand the structure of this design recipe. So with that said, let's go ahead and design a function that squares a given number. So I'll go back to the editor, and here I'm showing that we are starting from scratch. I don't have anything in the lib directory of my module. So let's go ahead and create our module file. So we are going to call it math.ex, and at the same time let's write our test file, which is going to be math_test.exs. So once we have that, we can open our files. So here is our math, and then we are going to open up the math_test on the right side, and we'll start to implement our function. So going back to our drawing board, the first step is to write the signature. So we'll start with our usual def module, and the signature starts with @spec, and we have to think about the name. Since it squares a number, square seems like a good name. It takes one argument, which has to be of the type number. So we are going to write the number, and then the output of this function will also be of the type number. So here is the step 1, where we have written the signature of our function. The second step is to write the purpose. That will come before the spec, and that will start with the doc, and in this case the purpose will be to produce square of a given number. So here is the step 2 of this function. which defines the purpose. Then we will move on to step 3 to write the stub of the function that will come after the signature, so that the function definition will start with the def, and the name we already know. So what should be the parameter name? I think we can just call it a number, because in the purpose we are saying square of a given number. So we are just going to simply call that a number and start our do block. Inside we are going to write one expression that simply produces the value of the type that we have defined in the signature. So that is of number, and the simplest number I could think of is 0, and there we have it. So here is a working syntactically correct function that creates the scaffolding of the function that we eventually would end up with. So the stub is complete. Now we will move on to writing some test cases. If you recall from the previous video, we start our test module just like a normal module, but we are going to write use xunit dot case, and then we start writing our tests. So that start with test, and in double colons we are double quotes we are going to write what this test will be. So we are going to say square of a positive integer. We are going to make an assertion that our square function of, let's say, 4 should produce 16. Let's write another test where we compute square of a negative integer. Here we'll assert math.square of negative 6 is gonna be 36. And let's write one last test where we are gonna do a square of a decimal number, that is a floating point number. So here we are going to make an assertion square of, let's say, 1.5 is going to be 2.25. So we have written 3 examples of how our function should behave, and those examples are written in unit tests, so we are able to run those examples. So we are ready now to write the body of the function, but remember that since we already have a working function and tests, we are able to run our tests using mixed test. And of course all of these tests would fail, but that is okay since we have not implemented our function yet. But the fact that we are able to run our tests using the scaffolding that we created is a nice step so that we can focus on the implementation using the information we have created so far. All right, the 5th step is to write the body of the function. And in this case, the input is really a simple number. So we can use some kind of algebra of numbers, if you will, to compute the output value. So how are we going to do the square of a number? Each language may have a different operator. Elixir has an operator to compute the powers of numbers, which is double star, and in this case we are going to compute the square of the number like so. So there we have it, very simple implementation. So we are done with this implementation, and then the last step is to test whether our implementation is correct. So we are going to again run our tests, and once we do, we see that all 3 tests pass. So we don't have to go back and change our function. But in case our tests fail, then we have to pay attention to both how the implementation is written, but also how the tests are written, because our tests could fail either because our implementation is wrong, or we might have written tests incorrectly. So there you have it, the entire recipe of how to design functions using Elixir.